Hello everyone and welcome. My name is Vitor. I'm team leader of PSEM, the Sustainable Energy and Mobility Project. Firstly, I'd like to thank you all for coming and for following our activities. I hope you're all in good health. If you're seeing us for the first time, PSEM is a student project of Técnico Lisboa, our university. In the team we have members of the Mechanical and Aerospace Engineering degrees, Electronics, IT, and Industrial Engineering and Management. Our goal is to design, build and optimize an electrical, lightweight and highly efficient prototype in order to compete at Green Power's races. Recently, we finished our 7th season in what was an unusual year, so to speak. In the beginning, in November of last year, we started to work towards our first objective. At that time, PSEM had only 10 members, a third of what we need for the proper workflow of the team. So, with a new and more rigorous strategy, we started recruiting and were able to fill all the vacancies we had with young, dedicated and motivated engineers. We truly did put together a great team, and you will see the results of that shortly. Having finished the recruiting phase, we were going to start optimizing GP19. In the previous season, due to all the delays that we had on its build phase, mostly caused by us not being able to outsource the machining of the molds, we cannot finish GP19 in time to compete. But this season, we reviewed all the parts and we were planning on having the car ready in April, to then test it and take it to our first race in Spain, at the Circuit of Navarra, in May. But unfortunately, for obvious reasons, this was not possible. For us, quarantine started, and GP19 hibernated at our workshop. It was only in June that we got back to the workshop, and after a few weeks of working on the car, we performed the first tests at our campus. And what an amazing experience it is to drive GP19. The steering is smooth and precise, and the transmission is responsive and torquey. What remained was to compete. Given the restrictions on traveling to the UK, the health risks, and even the financial ones in case of a last-minute cancellation of the race, all this made racing unfeasible for us. But there's one other positive we take from this season. Surely quarantine wasn't going to stop 33 young engineers that so eagerly wanted to innovate. That said, in the name of the whole team, I present to you the new car we designed this season. Finally, after 9 months of work, here we have GP21. I can't even tell you how proud we all are to finally be able to reveal the car. Let's go right ahead with the description of the car, starting with the structures. For the first time, the driver's cell will be made out of one single piece of carbon. This carbon tub replaces all the carbon bulkheads we had in GP17 and GP19, and it also includes the motor bay. In fact, the only bulkheads we have on the car is the top one that supports the steering column, the rear one where we mount the roll bar, and the battery boxes. Under this structure, we glue on the lifting points, made out of carbon fiber with a polystyrene foam core. On each lifting point, we'll have the locking pins for the lower bodywork, and then on top of it we place the upper bodywork and fix it in place with quarter-turn fasteners. All these blue parts are the protective foam components required by the technical regulations in order to protect the driver in a frontal or side impact. After having the structural design complete, we then proceed to the air optimization of the car and its bodywork. In order to have as low drag as possible, we designed a smooth surface front to back, avoiding features that disturb the airflow. Another key aspect is the reduction of the frontal area of the car, which we did by implementing this curvature on the lower bodywork. And finally, we have a new feature on the car. The driver cell opening is a region of low pressure and recirculating airflow, which ends up having a negative effect on the outer flow. So, to minimize this effect, we put two ducts on both sides of the opening above the driver's shoulders that allow the air to flow from the cockpit to the rear of the car. All this put together means that the car has under 5 newtons of drag and a CD of 0.12. Taking a look now at the steering system, we have a wheel again, as we did in GP14, so no more lever system. We mounted via a quick release system to the steering column that is connected to the front left wheel assembly with a tie rod. Please note that both steering arms are connected via the center link bar that ensures the correct Ackermann geometry. We've also placed a steering damper for better comfort of the driver during the hour-long race. The wheel assembly was intensively revised. The hub supports and the wishbones were topologically optimized, meaning that the geometry was defined according to the loads and constraints that they had to endure. We've also replaced the old axle with a through axle and a standard off-the-shelf bike hub. Much like the hub supports, the rear axle support was also topologically designed in a way that made it possible to reduce the weight by 70% when compared to the ones in GP19. We've kept the belt and pulley system given its high efficiency and performance as we've seen with GP17. The cooling system is lighter as well, but operates in the same way as the one in GP19. There's a 120mm fan on the outlet duct that sucks the air from the motor bay through the inlet, through the cooler, and then out the back of the car. As for our electrical components, we have the same motor and battery pack as before, both standard issue of Green Power. In terms of data, we have inertial measurement units that incorporate accelerometers, magnetometers, gyros. We also have current, voltage, and temperature sensors, and all this data is sent to an Arduino, which then not only stores it, but also uploads it to our server so that we can analyze it during the race. The power management system is now being tested. We've designed a pulse width modulator that ensures a better getaway at the start of the race without putting the motor at risk of a current spike. Having mentioned all the systems, only the manufacturer of the car remains. And it has already started. Our sponsors are always a great help, and we're grateful for the support they've been giving us all these years. We plan on having the car ready before summer, so we'll have plenty of time to test and prepare it for the races in September and October. We're also planning on going to Spain for the first time. We just need to build the car, and we'll be ready to conquer our objectives. Before finishing this presentation, I'd like to thank the whole team for the amazing effort and excellent work done throughout quarantine and in this time of virtual teamwork. An enormous thank you also goes to all the former members of the team that helped us in the R&D process. And finally, I'd like to thank our sponsors, our professors João Dias and Luís Sousa, our followers and subscribers, our colleagues, friends and family that believe in us and help us daily in our fight for success. I wish you all happy holidays, Merry Christmas, and a happy and healthy New Year. Thank you. Until next time.